When we talk about climate-optimized trajectories, we are talking about flight plans that incorporate climatic impact of aviation into the business objectives of the airline. Traditionally, aviation environmental impact has been driven by CO2 emissions, which are directly linked to fuel burn. However, in the last years, non-CO emissions have become prevalent and have attracted attention. These non-CO2 emissions, such as for instance condensation trails or aviation-induced clouds, depend on the atmospheric conditions the aircraft is flying through, and thus are not directly dependent on the distance or the fuel burn. In the latest reports by the International Panel of Climate Change by the United Nations, non-CO2 emissions derived from aviation count 2/3 of the total, and on the contrary, the CO2 impact of aviation can be considered to be 1/3 of the total impact of aviation. Thus, considering non-CO2 effects is quite important today. Talking about research, we have just finalized the SESAR exploratory research project FLYATM4E. The focus of the project has been in investigating aviation climate impact. We have been able to characterize its impact and develop the so-called algorithmic climate change functions. And we have been able to pass this information to a series of trajectory optimization solutions that are capable of quantifying the cost of mitigating climate impact. FLYATM4E can be considered a success story within SESAR because for the first time we've been able to encapsulate climate change information into an open source library that can be considered to be a preliminary meteorological service oriented to climate change, and this is aimed to become standard in aviation for the next years to incorporate climate change. That's one thing. On the other, the second solution has to do with the development of different aircraft trajectory optimization algorithm, and we have been able to initially quantify the cost of flying in a climatically speaking friendlier manner. All in all, we have observed that there is a mitigation potential of 20 to 50% in terms of aviation climatic impact at a cost ranging from 1 to 3–4%. And this is a path we need to continue, but this has been quite remarkable.